Hello and welcome in a new video. In this exercise, we will use the work kinetic energy theorem combined with the fundamental relation of dynamics to solve this physics exercise. So, we have a truck traveling at a speed of 40 km per hour. It's braked. It comes to a stop after 3 meters. So they said that if the initial speed is 40 kilometers per hour and that it brakes, it will come to a stop. Coming to a stop means that we have the final speed is equal to 0 after 3 meters. So we have initial speed 40 kilometers per hour, we have final speed equal 0, and the distance traveled is 3 meters. The question is, over what distance will it stop if its speed is 80 kilometers per hour? They are saying that if the initial speed was 80 kilometers per hour, now Vf equals 0 for which travel distance. In other words, we can write this exercise as following. So we have V initial 1 equal 40 kilometers per hour. The truck will stop, so it will have a final speed equal 0 at x1 equal 3 meters. Okay, the question is, if V initial is 80 kilometers per hour, then V final 2 will be equal to 0 after which distance traveled. Okay, so in the first line we know V initial and V final in the first case, so one refers to case 1. After traveling a distance x1 equal 3 meters, then we have to complete case 2 by finding x2. Well, let's use the work kinetic energy theorem, where the sum of the work done by all the external forces equal the variation of the kinetic energy. Let's apply the work kinetic energy theorem on any case. We can write that the sum of the work done by the external forces is equal to the work done by weight plus the work done by the normal reaction plus the work done by friction. Why is there friction? In fact, they said in the given that the truck is braked. When a truck is braked or when we have brakes, this means that we have a friction. So we have to add this force, we have to add friction, we have to take into consideration friction because friction will cause the truck to stop. What are now the forces that are acting parallel to displacement? We just have friction. So the work done by mg will be equal to 0 and the work done by the normal reaction will be equal to 0 because mg and n are both vertical forces and they are perpendicular to displacement. So their work will be equal to 0 and there only remains the work done by friction. By definition, the work done by any force is equal to the integral of this force, the vector form, scalar displacement vector. The displacement vector in our case is dx. It's in one dimension. So now f scalar dx is equal to the magnitude of the first vector f times the magnitude of the second vector dx times the cosine between f and dx. So what is the angle between f and dx? We know that the friction force is always opposite to displacement. This means that if the displacement is to the right, then friction is directed to the left. This means that the angle between f and dx is 180 degrees, and cosine of 100 degree equal -1. So the sum of the work done by all the external forces will be equal to minus integral of f dx. Okay, do we know what is the expression of the friction force? No, but we can find it by using the fundamental relation of dynamics. So let's find the friction force from the fundamental relation of dynamics. So let's consider our system, the truck, and we can write that the sum of the external forces is equal to MA, and the forces are mg, vertical downward, plus N, vertical upward, plus friction force equal MA. So since we want to find the friction force, and the friction force is equal to mu times N, we have to find first what is N. So let's project this expression along the y-axis. This will give us, so let's consider the positive direction of y as upward. This means that the projection of mg along y is equal to minus mg. The projection of f along OY is 0 because f is perpendicular to OY, and the projection of n along OY is plus n. Now the projection of the acceleration vector along y is equal to 0 because the displacement is only taking place along the x-axis. This means that AY is equal to 0. In fact, the truck can move to the right. It cannot move upward or downward. Okay, that's why AY is equal to 0. And therefore, we can get that the normal reaction is equal to mg. And we can finally deduce that the friction force is equal to mu, the coefficient of friction, times mg. Now let's put this expression here to find the sum of the works done by the external forces, and you will find that the sum of the works done by the external forces is equal to minus integral of f times dx, where f is equal to mu mg. Now x is going from 0 to x final, where x final, let's say, it's the same as x. So we can deduce that the sum of the works done by the external forces is equal to minus mu m gx. Okay, so this was to find the term before the equal in the work kinetic energy theorem. So we found the sum of the work done by the external forces, and we can write that minus mu mgx now is equal to delta kinetic energy, so half mvf squared minus half mvi squared. Now we know that for the two cases that we have, the final speed is equal to 0 because they said that the truck will come to a stop after traveling a certain distance. So coming to a stop means that the speed is equal to 0. So V final in both cases will be 0. And therefore we just have mu gx equal half mvi squared. So we just simplified with m, and we multiply this expression with minus 1. This means that if we have the initial speed, we can deduce the distance traveled by the truck when it comes to a stop. So if we apply this equation on case 2, in order to deduce x2, we have to know what is mu. But in the given, we don't know what is mu. So what to do? In fact, we have two methods to calculate or to write this problem, to write the answer to this exercise. In fact, we can apply this equation on case 1 and on case 2, and then we can eliminate mu to find x2, and this is what I will do right now. So let's apply it on case 1. We will have for x equal x1, mu g x1 equal half mv initial squared for case 1. This expression is denoted as expression 1. Now let's apply this equation on case 2. So we can write for x equal x2, mu g x2 is equal to half mv initial 2 squared. And this expression will be denoted as expression 2. Now we want to get rid of mu, so let's divide 1 by 2. So 1 divided by 2 will give x1 over x2 equal v initial 1 squared over v initial 2 squared. We want to deduce x2, so let's write x2 as x1 times v2 squared initial over v1 squared initial. So we have all the values needed. We have x1, we have v2 initial, we have v1 initial, and we can easily find the value for x2, and we'll find that x2 is equal to 12 meters. The second method to find x2 is that once we found this expression, we can apply it on case 1 to deduce the value of mu, and we can put it to deduce x2. Okay, so in this exercise, we applied the work kinetic energy theorem combined with the fundamental relation of dynamics to solve the exercise. Why? In fact, once we find F, friction force, how do we know the expression of the friction force? We have to apply the fundamental relation of dynamics. Okay, this is the easiest way to find the expression of friction. Why did we think about working on the work kinetic energy theorem? Because in fact, we have V initial 1, we have V final 1, we have V initial 2 and V final 2. So we have like the kinetic energy initial and the kinetic energy at the final state. So we can deduce the variation of kinetic energies. We can deduce easily what is kinetic energy final and what is kinetic energy initial. Okay, if you want to apply the theorem of linear momentum, then there will be the term integral of f dt. In this exercise, we don't know any information about the time that the truck puts to come to a stop. So we don't have any value for time, but we have a value for the distance traveled. Therefore, we didn't apply the theorem of linear momentum in this exercise